Hi guys, this is Nagoor Babu from DURGASOFT Solutions. So in previous videos already I have discussed about differences between Java and others. Just 2 points we completed. First one is C and C++ are static programming languages and Java is dynamic programming language. And another difference, preprocessor is required in C and C++, but preprocessor is not required in Java. So today in this video I am going to discuss one more difference between Java and others. Now the difference would be difference number 3. C and C++ are static programming platform dependent programming languages, but Java is platform independent programming language. So these are the difference. This is the third difference we need to identify. C and C++ are platform dependent programming languages, but Java is platform independent programming language. Before understanding C and C++ platform dependent and Java is platform independent, before understanding this, first we have to understand when we are able to say one programming language is platform dependent programming language, when we are able to say one programming language is platform independent programming language. If any programming language allows its applications to compile and execute on the same operating system, then this type of programming language is a platform dependent programming language. If any programming language allows its applications to compile and execute on the same operating system, then this type of programming language is called as platform dependent programming language. C and C++ are platform dependent programming languages. How can we describe C and C++ are platform dependent programming languages clearly? Let's say for example, I will take a C program. This is a C program. C program is started with which one? .c extension. Then after that I will take compilation process. So this is compilation process. After completion of this compilation process, here we are able to get .exe file in the case of C. .exe, something else. Now here what I am going to do now, here I am going to use Windows operating system. C program we compiled on Windows operating system. Here we are getting some .exe file. After getting this .exe file, I want to execute this program. After execution of this program, automatically we will get some outputs. For execution, as per the definition, what exactly the operating system we have used for compilation, same operating system we have to use for execution. So as per the definition, as per the platform dependent nature, same operating system we have to use for compilation and execution clearly. For example, to prove C and C++ are platform dependent programming languages, to prove that in place of this Windows at runtime, I want to use, for example, Linux operating system. This is Linux operating system clearly. For example, if I compile this C program on Windows operating system, automatically .exe file is generated. This .exe file contains directly executable code. Directly it able to contains executable code, zeros and ones only. So this executable code is provided as per Windows representations. As per Windows representation. Why? Because our C program is compiled on Windows operating system. So with the same Windows operating system representations are existed in .exe file. It means that operating system to operating system data representations are varied. Windows is following one type of representations, Linux is following another type of representations, Unix is following another type of representations. Like this, operating system to operating system data representations are varied. So C programming language, C program is compiled on Windows operating system. Automatically .exe file is generated. This .exe file is provided as per Windows representations clearly. Then after that, I am trying to execute this program on Linux operating system. Linux system we want to use. If we use Linux operating system for runtime, we must require that executable code as per Linux representations. In a Linux, if you want to execute any C program, the generated .exe file must follow Linux representations. But in this context, what happened? We compiled our C program on Windows, so we are getting Windows represented .exe file. But here at runtime we are using Linux. If we provide Windows represented .exe file on Linux operating system, the internal data representations are very totally. Some mismatch is available between the provided .exe file and a target runtime kernel. Some mismatch is going on. So because of this mismatch only, our program will not be executed clearly. But if you want to execute our program, what we have to do there, at runtime we have to change our operating system. Initially we have used Windows operating system for compilation. The same operating system we have to use at runtime also. If we are using different operating system at runtime here, Windows represented .exe file will not be executed on any other operating system. So if you want to execute Windows represented .exe file, then at runtime, then we must use the same Windows operating system for execution time here. So that we have to remove Linux here. In place of that, the same Windows what we used for compilation we must provide. Because of this nature only, C and C++ programming languages are platform dependent programming languages. This is another point here we can identify it now. So this is mainly reason why C and C++ are platform dependent programming languages. This is one point. And in another way also we can conclude that in the case of C and C++ programming languages, memory allocation for primitive data types is not at all fixed one. That is totally depending on the operating system which we used. For compilation, if we use Windows operating system, as per Windows way, it able to allocate the memory for primitive data types. If we use Linux operating system for compilation, no, as per the Linux way, it able to provide some memory allocation. And moreover, if you go for 16-bit operating system, 32-bit operating system or 64-bit operating system, again memory allocation for primitive data types is going to be varied from one operating system to another operating system. It is not fixed in all the operating systems. In this way also we can conclude C and C++ are platform dependent programming languages. This is one point here. Similarly, how can we say Java is a platform independent programming language? First of all, if any programming language allows its applications to compile on one operating system and to execute on another operating systems. If any programming language allows its applications to compile on one operating system and to execute on another operating system, then this type of programming language is called as platform independent programming language. Best example is Java. Java is a platform independent programming language. Why? Because Java is able to allow its applications to compile on one operating system and to execute on another operating system. So by this we can conclude Java is a platform independent programming language. But how can we prove this one? How can we say Java is a platform independent programming language? Just I will give one small representation, try to understand it. For example, I will take Java program. This is our .java. Just I want to compile this. This is compilation. When we compile this, automatically we are able to get .class file. In case of C and C++, we are getting .exe file after compilation. But in the case of Java, after compilation, we are able to get a .class file. After getting this .class file, I want to run this .class file in n number of operating systems clearly. For compilation purpose, I am going to use Windows operating system, and for execution purpose, I want to use different operating systems. Now here, I want to go for one execution process. This is one execution process. Here, I want to get which one? Output. For execution process here, I want to use which one? Linux operating system. And I'll go for another execution process here. Now this is another execution process. In this execution process also we are able to get some output. Now here I want to use Unix operating system. I'll go for in the same way another execution process here. This is execution. So here also we are able to get some output here. So here I'm going to use like Solaris operating systems. Next one, in the same way I'll go for another execution process, last one. Then here also we are able to get output, but here operating system what I am going to be used here, this is about the same Windows operating system we are able to use. Clear cut information. As per the definitions here, what I am telling clearly, here the point is, whenever we are trying to, when we compile our C program on Windows operating system, automatically we are able to get .class file. Here .class files here we are getting there. In this .class file what we are having, some bytecode we are having there now. .class file contains bytecode. What is this bytecode actually? It is not directly executable code, comma, it is an intermediary code. It is an intermediate code. It is neutral to every operating system, including Windows. See, when we compile our Java program in Windows operating system, automatically a .class file will be generated. This .class file contains bytecode mainly. What is this bytecode actually? This bytecode is not directly executable code. This bytecode is an intermediary code, and it is not representing any of the operating system representations, including Windows operating system, where we have used Windows operating system for compilation there now. After completion of which, this .class file I want to execute in all the operating systems. Whenever we want to execute this .class file on Linux operating system, first we must require the same bytecode in Linux representations. If we want to execute any program on Linux operating system or Unix operating system or Solaris or Windows, first of all our bytecode must represent our local operating system representations like Linux, Unix, Solaris or Windows, what we want to use there. In that way only our bytecode must be available. But here we provided an intermediary code, but there we require local operating system represented bytecode. So here again we are getting some kind of problem here now. See here what we provided, we compiled our Java program on Windows operating system, a neutral bytecode is generated. If we want to execute this neutral bytecode on any of the operating system, this bytecode must follow local operating system representations. But here bytecode is which one? Neutral bytecode. It is not following any of the operating system representations, but here we must require the local operating system representations. Exactly in this particular context, to make Java as a platform independent programming language, and to execute Java program in a different operating systems now, in this particular scenario, Java has provided, it means that Sun Microsystems has provided a translator clearly. Sun Microsystems has provided a translator, a separate translator is provided here now. What exactly the translator here now? So this translator here, this is one converter here we are getting there. What is the job of this converter? It will take neutral bytecode as an input and it will convert that neutral bytecode into the local operating system representations, Linux representations, and it will be executed, output we are able to get. And here also we are using one more converter or translator, whatever it may be. It will take neutral bytecode as an input. This converter will convert that neutral bytecode into Unix representations and generating some output. Here also we are going to use a separate converter. This converter will take neutral bytecode as an input and it will be converted to local operating system representations like Solaris representations and generating some output. Here also neutral bytecode. Here also we require one converter. This converter will take which one? Neutral bytecode as an input that will be converted to Windows operating system representations, executed that and finally getting output. In this overall scenario, these converters are provided. These converters are converting the neutral bytecode into the local operating system representations. In this scenario, Sun Microsystems has provided this converter and as well as this execution, both the processes in the form of a single device. That single device is called as which one? JVM, Java Virtual Machine. Similarly, here also converter and as well as which one, you know, this particular execution part, both are provided in the form of a single component that is called as JVM. Here also we required both conversion and as well as which one? Execution. So in the form of a single component that is called as which one? JVM. And here also we are getting JVM care. Here this is about JVM care now. In this scenario, how many number of JVMs here we have used here now? It is not like single JVM. So overall 4 JVMs are provided. So why these are 4 JVMs now? Why not it is a single JVM here now? The conclusion is very clear. Java programming language is a platform independent programming language because of these conversions. That means JVM only. Because of JVMs only, Java programming language is a platform programming language, but JVM is platform dependent tool. Java is a platform independent programming language, but JVM is which one? Platform a dependent tool. Not only this JVM, Java programming language is platform independent, but totally Java software is a platform dependent. Inside this Java software, so Java compiler is existed, JVM is available, Java doc is available, Java P is available, like number of tools are available. All these tools are platform dependent, but Java programming language is platform independent. Programming languages is a set of syntaxes and set of instructions. That is called as programming language. But Java is which one? Software is a collection of programs here. These collection of programs are running on the basis of the operating systems only. That means they are dependent on the operating system only. No? But Java programs, Java programming language is a platform independent programming language. So here, because of JVMs only, we are getting execution of this Java program on multiple operating systems. And moreover, we compiled our Java program on Windows operating system clearly. So this is about Java and its platform independency nature clearly. After completion of C++ platform dependent and Java is a platform independent, automatically here we have a question. One important interview question is existed here in this case. No, that interview question would be, here we have a question. That interview question would be, what are the differences between .exe file and .class file? What are the differences between .exe file and .class file? This is one of the interview question. And a .class file. The very first difference, .exe file is available maximum C and C++. .class file is existed up to which one? Java. This is first one. .exe file is existed up to C and C++. .class file is available up to Java. Difference number 2. .exe file contains directly executable code. .exe file contains directly executable code, but a .class file contains bytecode. It is not directly executable code. Comma, it is an intermediate code. Next one, .exe file contains directly executable code, but a .class contains bytecode. It is not a directly executable code, it is an intermediary code. Third difference. .exe file is a platform dependent file. On which operating system we compiled C program, the same operating system we have to use to execute our program. So this nature is which one? Platform dependent. .exe file is platform dependent file, whereas .class file is platform independent. Why? Because it contains neutral code only. It is not having any dependent code here now. This is another one. And fourth one, it is very simple to introduce viruses kind of softwares inside the .exe files. Viruses kind of softwares are very simple to introduce inside the .exe file, but .class files are not allowing viruses kind of softwares in the simplified manner. That means it is very difficult to introduce virus kind of softwares. But here it is very simple to introduce viruses kind of softwares inside .exe. It is very difficult to introduce or to insert viruses kind of softwares there now. Next one, .exe file will provide lesser security, but a .class file will provide more security. .exe file will provide lesser security, but a .class file will provide more security. So these are the differences between .exe file and a .class file. First one is .exe file is existed up to C and C++. .class file is available up to Java. .exe file contains directly executable code, but .class file contains bytecode. It is not directly executable code, it is an intermediate code. .exe file is a platform dependent file, but a .class file is a platform independent file. It is very simple to introduce viruses inside the .exe file, but it is very difficult to introduce viruses in a .class file. .exe file will provide less security, .class file will provide more security. So these are the differences between .exe and .class clearly now.